Yes, hello once again. This is Professor Grenfell. Good morning to you, by the way. This is Professor Grenfell, and we're going to be doing a quick example from Chapter 10, Section 3. By the way, this is Math 12 Statistics, in case you didn't know. So here we have example 10-12 on copy machine maintenance costs. And I've gone ahead and listed the data. We have machines A through F here, their age in years, yes, I should say. There we go. The monthly cost, Y. And the first, and also we have the equation of the regression line here. So Y prime is predicted by 55.57 plus 8.13 times X. So the first thing that we're going to go ahead and do is make a table of values. We have X in the first column, Y in the second column, Y prime or Y apostrophe. I'm going to call it Y prime. In this fourth column, we're going to have it be Y minus Y prime. And then finally, in this last column, we're going to do Y minus Y prime. And that will quantity raised to the second power. So we'll, first of all, copy all of this data into the X column. There we are, 4, 6. And then second, we'll just go ahead and copy and paste this. I'll do it the smart way this time. Copy and paste that into the Y column there. All right, now we're going to go ahead and use the equation of the regression line right here in order to compute Y prime for each of these X values. So that will be the predicted value, and we'll be able to see then how different the actual Y value and the predicted Y value are, and we'll record that in this column. And then finally, we'll go ahead and square all of those and place that in the fifth column there. All right, so the first thing I'm going to do is type in the formula that will enable us to compute the equation for this regression line. So I'm going to type in 55.57 plus, there we go, there's my plus button, 8.13 times, and then we're just going to say the X value. So I'm going to click on this cell, and that will do that. Oh, look at that. It's so helpful. We'll go ahead and just autofill those results. So that will just go ahead and repeat that calculation on down the line, and we'll have all of those values filled in now. Okay, so in this column right here, we're going to say equals, and we're going to take the Y value and subtract away the Y prime value. So that's F2 minus G2. We'll go ahead and do that. And then it's very helpful. Suggests this autofill of filling in that entire formula for all of those. And that is exactly what we want to do. We are going to do that same calculation. The Y value minus the Y prime value, write it in here. Y value minus the Y prime value, write it here. So it is just repeating all of that. So we don't even have to copy and paste that. And then last here, write equal sign. Go ahead and highlight this square or type in H2 if you prefer. And hit the Shift 6 to make the caret key and squared. So we're going to go ahead and do that. And then very helpful of it, it's going to autofill all of those values in. All right, the last thing that we're going to do is we're going to just total this up. And look at that, it's got a great suggestion for it, the sum of all of those values in that column. So we'll just say, yes, do that. Okay, and we're going to resume recording and share the iPad screen so I can write. And let's go to screen mirror, of course, and click on the Zoom meeting. And then we'll open up my handy dandy program here to show you what's on my screen. So what we have to do in order to fulfill what this problem is asking for is compute the standard error of the estimate. So that is S subscript EST, S sub est. And the formula for this, the traditional formula, is we'll take the sum of y minus y prime whole thing squared, right? And add up all of those squared differences. And then finally divide by the degrees of freedom, which are n minus 2. So that's all we're doing right there. And rather than doing this all by hand, I'm going to go ahead and switch back now to the handy dandy Excel sheet, which is this one right here. All right. So notice we are using this total of all of these differences squared. All right. And we'll just go ahead and calculate that using the built-in computer that we have right here. So this formula is going to be a little bit interesting. We'll write SQRT parentheses. So that is square root, not squirt, but square root. And then we'll just go ahead and highlight this cell right there, because that is the sum of all of the squared differences. And then just divided by, in this case, we could say count them up and tell me how many there are and then subtract 2. But notice here, we just have 6 different values. We have 6 different machines and so on and so forth. I don't want to divide by those values themselves. I want to just take 6 minus 2, and without a calculator, we can just put that in as 4. And so that returns a value of 6.514. And we'll leave it at that because the next digit is a 1. And so we'll just say S EST, kind of looks like cest, but it's not really a word, is 6.514. All right, so we'll stop the share right now and we'll call an end to that problem. So that was just an illustration on how to compute the standard error of the estimate. And I'm back on after a brief pause, since I said, well, might as well go ahead and continue this standard error of the estimate computation. This time we're going to do it slightly differently. So this is actually example 10-13. I'll go ahead and share my iPad screen once again. Okay, screen mirroring, there's the Zoom session, don't stop mirroring. All right, so there we had the previous version of the standard error of the estimate formula. And I'll just remind us in 10-13, example 10-13, we're going to be using this formula for the standard error of the estimate. And we'll just kind of note the difference in the computation here. So here the formula is, without looking at it, I've got the sum of the y squared values minus a times the sum of just the y values minus b times the sum of the, hang on, I've got to make my square root a little bit bigger, the sum of x times y. And then all of that is going to essentially replace the numerator here. So believe it or not, that numerator is a little bit easier to compute if you're doing this by hand, or even if you're doing it using computer algorithm. It's a little bit less operations for the computer to do, so it can actually crunch it out a little bit faster. It's less stuff to type into your spreadsheet if you're using the spreadsheet to do it by hand. So let's go back to the spreadsheet and show how, let's see, there it is, show how this procedure would be different if you wanted to do it by hand or use another spreadsheet. So here I'm gonna go ahead and make a column for X values, a column for Y values. What else do we need in here? We need to have Y squared. So Y to the second power. And we also need X times Y. And let's just go ahead and make all of these center aligned, just so it's a little bit nicer. There we go. Looks nice right now. All right, so we'll go ahead and copy and paste all of these values and all of these values, the X values and the Y values, into these two columns right here. Just go ahead and paste those in. And, you know, not that I'm a perfectionist or anything, but kind of scoot those over a little bit, so get a little bit more room. Okay, so when doing this procedure for this version of the formula, we're going to go ahead and just look at what's in each of these columns, or in this column, look at each of these values that are in column L, or the Y values, and go ahead and square them, either by hand using pencil, paper, calculator, or just have the spreadsheet do it. So it would be this value raised to the second power. And sure enough, it's going to helpfully suggest that we just do that same procedure and square all of those Y values. Then over here, what do? We go equal sign this times that. Enter. And normally we'd have to copy and paste that or re-enter it every single time, but this one, it's very helpful. It's offering to just fill it in for us. I'm going to leave a little space this time so I can write the sum for each of these. Okay, and at the bottom of each of these columns, we're going to go ahead and have Google Sheets go ahead and add it up for us. So I'm going to say equals sum, and well, let's have it be not L2 to L8 because I don't want to add the word sum. Can't add a non-numerical value. We'll have it be L2 to L7. There. All right, and so now if I copy and paste this and just shift it over to the next column, it will add up everything in this column. And then similarly, we'll do the same thing right there. It added up all of the X times Y values. All right, and I'm back on again. So I wanted to just go back to the iPad. So that'll take just a moment. Yeah, gotta click on screen mirroring. A little bit tedious, but I don't know how to get it to work better. All right, so here is the equation that we're going to need to use. In this case, we have the standard error of the estimate is the square root of the entire quantity, the sum of y squareds minus a times the sum of the y's minus b times the sum of x times y for all of those data points that we're putting in, and then all divided by the square root of all divided by n minus 2, and that is, notice, inside the square root. Okay, so let's just keep that in mind. The a and b that are in that formula are the coefficients, the a and the b value, that are from the equation for the regression line. So here, I'm just going to do the same calculation. Essentially, I'm just going to say S subscript est, and in the next row right here, I'm going to do the square root. So I'm going to say equal sign SQRT, parenthesis. Now we're going to say we have to do a division. So and we have a whole lot of terms in the upstairs part of that square root. So I'm going to include a second parenthesis there. And then I'll just go and pick out the values that we want to include. So we've got the sum of the y squareds, and then minus a times the sum of the y's. So a in this case comes from over here. Oh, no, not that whole square. I just wanted to highlight it. It's 55.57, not A10 itself, just that 55.57 from A10 times the sum of all of the y values. And then minus here, we're going to use, better not click on it, the 8.13. That's our B coefficient. So type it in, 8.13 times the sum of x times y's. All right. And then we'll close off that first parenthesis. So that says do everything in the top part of that equation that we were using first, and then divided by n minus 2, which in this case, there are 6 data values or 6 ordered pairs. So we're going to divide by 6 minus 2, which is 4 without a calculator. And notice, oh, I got something different there. Must have made a little small error. So let's pause and figure out where I went wrong. Oh, so yeah, so I just looked and double checked all of my work, and I didn't find any places where I had mistyped this. And then I went ahead and looked at the example in the book, and you will notice that in the book, they found this standard error of the estimate using this calculation to be exactly 6.483, just like I had. All right, and so the difference in this is just due to the rounding that takes place when you come up with the values for A and B. It gives you a slightly different calculation, but that's okay. So either way you calculate the standard error of the estimate, you have a slight margin of error for that, unless it specifically instructs you on how to use or which formula to use, then you won't be penalized if it is slightly off. They just say calculate the standard error of the estimate. You can just do it however you want. If the problem says to do it a specific way, of course, you need to use that specific formula to do that computation because they won't be flexible. All right, so that was 2 quick examples, example 10-12 and example 10-13, and I'll sign off for now.